Okay, thank you very much for the kind introduction. My name is Hansen. I'm from Chambers. I'm also the Vice President of the Building and Estate Management Alumni from NUS. So today, I'd like to just do a quick talk on the digitization in facility management from a practitioner's view, a facility manager's view. So according to the World Bank, about 70% of the world's population will be living in large cities by 2050. To cope with these increasing populations, tightening budgets, rapid urbanization, and climate change, civic managers and facility managers around the globe are looking at better ways of doing more with less, and doing this through automation technologies. So the smart societies they are creating offer potential for efficiency savings and better service delivery. So actually, in the last 4 or 5 years, technology has really taken my industry by storm. It's good. It's difficult, but it's good. It leads to higher efficiency and greater productivity. That's what drives us towards technology. It also creates a more sustainable and eco-friendly footprint. And it creates a better and more predictive maintenance capability for people like us, for effective operations and better asset management. So actually moving forward, this is the direction, not only automation, but digitization as a whole. It is beneficial to my industry to continue to pursue this area of improving our line of work. So today I'll just introduce a few technologies that we see in the market, especially for those of you who are also practitioners that are maybe looking at this event or at this talk for some insight into what can be done to digitize your workflows in your respective organizations, whether you're a building owner or whether you're a managing agent or whether you're an FM company or whether you're a service contractor. So these are some of the things that we use. So this first one that I'm putting on the screen, it's actually a feedback module where a lot of people use the app that I'm showing here to be able to send feedback to my company on these examples like spilled drinks, faulty lights, faulty aircon. But what we normally have at the end of the feedback is a physical person that would actually perform the role of answering the feedback. And then it adds a human touch to it. This is the normal way or the traditional way. So using this app, using some artificial intelligence, it allows us to answer back using a bot, a chat bot. Thereby, it reduces greatly the manpower needed to reply to this feedback. So for a project that we use this on, there's about 6 buildings or locations. So it greatly handles the feedback for us and helps us with our work. So digitization is helpful using this method for us. This is another example of accounting and property management software where we can use the cloud, the internet, to do our accounting. So when the lockdown came, our account staff all can work from home, and it's web-based. Along with this, it also allows users, they could be residents, they could be tenants, they could be office owners. They would allow the building owners to use the app to also give feedback where it will be answered by a human being. This one don't have AI. But on top of this, this software also helps us to do preventive maintenance scheduling also. which means when is your pest controller gonna come? Maybe the third Wednesday of every month. Or when is your landscaper gonna come? The second Wednesday of every month. Or when is your lift contractor gonna come and do his servicing? Maybe the last week of every month. And then there's a date to it. So by using this software, so it helps us to actually key in or helps us to manage all our servicing within one software, and it prompts us when each service contractor is supposed to come. So we find that that's quite good. It reduces human error by a lot, and it also allows us to create a database for all our suppliers. So I got thousands of suppliers inside this software now. Then whenever I need to refer back, I don't need to remember who I dealt with. I just go back to this software. So if I want a security discipline, boom, using this software, I got maybe 100 of them, they'll come up. So I got my own little database for my company. Also does asset listing. So my clients, they have 100 chairs and tables. They want to know, they want to asset tag it. We can also do that with software. So this is another example of a software that would help in our work. So digitization is also helpful here. This is another example of an app we use for our projects where you can book facilities, you can make announcements to owners about maybe a fogging or maybe a meeting that's happening. You can allow people to apply for their renovation forms on the app. So you don't have to go down to a management office, take a piece of paper, fill it up and hand in. You can just do it through the app and e-submit an e-form. So it makes it easier for renovations, for moving in and out. And last but not least, it also allows general feedback where you can take photos and send stuff to us on whether a light bulb is spoiled, a toilet is smelly, pump is not working or too noisy, that kind of thing. So this would be another example of how digitization would help us in our area of work. So those few are on softwares, but moving forward, there are other more obvious things that help us in our work. For example, robots. So robots can be used in repetitive tasks. So in repetitive tasks, for example, for air cons, the ducting in a shopping center, the ducting is very, very long. To clean the ducting or to patrol the ducting, you can use robots to go inside the ducting and then just clean it. You don't even have to look at it. It will clean and it will give you a report after that. I just wanted to show you all one live example of a cleaning robot that we use at the office. And by using this robot, we actually don't have to use a human being to go and vacuum the thing. So we push this robot throughout the premise once. The robot remembers the route. Then you can do it 1,000 times later, that same route. And it's quite clever these robots. When it meets somebody, a human being, it will know how to go around the human being. Whether it's a chair, a table, a new person standing in its way, it's quite cute. It will go around it. So it'll get out of jams, it will keep moving and clear the place. So with robots, we always ask ourselves, when you want to decide whether or not you should use a robot, ask yourself a few questions like, cost-wise, you buy the robot or lease the robot, is it more expensive than what you're doing now? Because maybe you don't use a whole cleaner to vacuum one floor. Maybe you use only half or a quarter of a cleaner. Then the cleaner actually does a lot of other jobs. So if the area is not big enough, then maybe a robot is not economically viable. Okay, market support, does it have a supply chain? Means got people sell or not this thing? So if there are people that sell this thing and you have a lot of choices, then you can go and do some market study. In Singapore, I dare say there is a market now. There's market support for this. Effectiveness is whether or not it's cleaner using robots. So nowadays, you can actually have this proof of concept thing where you tell the vendor you want to try first. You pay a small fee, you try for 1 month. If it works, then the proof of concept works. They'll give you some readings on bacteria level, on dust level, and a lot of other parameters. Then you can see for yourself. You can also feel yourself whether it's cleaner or not. And then whether the technology is mature or not. Actually, this technology is quite mature. I think robots have been around for quite a long time already, at least in my industry for the cleaning side. Okay, next I want to talk about a little bit about Internet of Things. Internet of Things is basically about sensors. To me, my understanding is basically about sensors. So when we do Internet of Things in our projects, we put a lot of sensors all around the building, we link them back to somewhere, and then we try and track everything. Okay, so some examples are like you put a lot of sensors in the toilets. You can track the ammonia level, smelly or not. You can track the number of people going in. You can track put a sensor in toilet paper. If the toilet paper goes down to a certain level, then you can also track that the toilet paper level is low. Soap dispenser also can. Dustbin too full also can. So this is very, very simple kind of tracking. But you can have more sophisticated tracking like M&E equipment on your chillers, AHUs, on your pumps. And this is where it gets very interesting. Using some very good sensors, you can predict when the thing is going to spoil. So I want to introduce Mr. Ted Chen later on. I want to introduce him from Evercomm to elaborate a bit more on this because he's doing a project with us also, and then he's helping to predict also when certain equipment can spoil. It's very clever. So this is the Internet of Things. Last few slides already. This one is on the digital twin. Digital twin means you have a build. For us we normally manage buildings. We call it assets of buildings. The building has a lot of equipment inside. Got lift, got pumps, got water tank, got aircon, got lights. So what we do is we create in our computer a digital twin, a 3D model of the building and all the equipment inside. We link it up via sensors, then the digital twin will be able to guide us on when something is spoiled or not running, or even better, when it's going to spoil. Then it will predict things. So it will help us in cost savings also with this digital twin technology. But the thing is, digital twin is expensive to do. So it's something that, as a facility manager, we will think twice whether there is a real need for this. But I'm just trying to explain to you technology being utilized now in our FM industry, facility management industry, can really go to an extent where it can help us a lot in our work. So it'll be good to learn or it'll be good to use more technology in facility management. Okay, this is one of my last slides. If you are just beginning, for those of you who are my competitors or who are also in my line of work, for those of you who are beginning your digital transformation from the old way, pen and paper, and do your physical checks to the new way, maybe you can start with building something from scratch. Maybe you know what you want already. But if you know what you want already, then you could contact some app developers. Like for example, this one the name is Royal Greyhound. They actually develop an app for PSA, our port and then they will sit down with you and then they will listen to your pain points, what your problems, understand your business workflow, right? Then they create the app for you. And I understand it's like $1,000 a month, but thereafter you can use it for a lot of projects. So this is a good start. The investment is not big, and instead of me buying big softwares, hardwares that cost maybe 5-digit, 3-digit, 6-digit, this can be a nice way to start. So this is something that that I could propose as a starting point. Okay, so that's my brief introduction on digitization in the FM industry. Thank you for listening to me. So now I'll hand over you all to the main part of today's talk, which is Mr. Ted Chen's portion for today. Thank you very much.
Thank you, Hansen. And next, our speaker is Mr. Ted Chen, as Hansen mentioned, co-founder and CEO, Evercomm Singapore Pte Ltd. And Ted will be presenting to us. His topic is leveraging on machine learning to transform workflow automation for smarter facility management. So over to you, Ted.
Thank you. Let me share my screen quickly. Yes, thank you, Hansen, also for mentioning some of the work that we are doing. I'm happy to deep dive a little bit further on some of the places where we are now implementing what people hear a lot about machine learning into the smarter FN applications. So just a little bit background about Evercomm. We have been around since 2013, and our journey has always been, even back then, about how to make machine learnings, AI, these kind of advanced analytic into different applications. And we started in, because back then when we first started it, only the heavy industrial high-end sector can afford these kind of services. So we started in really semiconductor manufacturing. We started in traditional manufacturing and even oil and gas. And then over the years, as you know, as hardware sensors become cheaper and cheaper and more powerful, and also as servers, computers, all these becomes much cheaper and more powerful, probably around 2018, 2019, we were able to make a lot of these advanced algorithms even applicable and implementable in the facility management or in the commercial sector rather than the industrial. So I think when it comes to machine learnings and AI, it has really came a long way, and more we have been engaged by different governments directly to see how we can leverage our machine learnings and AI to help the labor, manpower challenges that are being facing a lot of the country. So we do see that more and more machine learning and AI will be used in the workforce to help address some of these manpower crunch or bottleneck issues. So this is really the background of what we have done. I will also share two examples of, these are the example that since the government has made a nice video around it, I will play the video later. But in a nutshell, you can see that different agencies are putting a lot of effort, wanting to see what kind of applications can we put in for AI and for machine learning across different sectors. So we have done our very first commercial buildings, putting into machine learnings and AI to simplify workforce, to reduce the dependency on autonomous, not autonomous, but very tiring labor work. With the first one that we have piloted together, funded by the Singapore Tourism Board, was actually for the Park Royal Hotel. And subsequently, 2 years later, another agency, National Environmental Agency of Singapore, they also approach us together with the hotel group and say, can we further extend the AI application, not just into managing chiller plant, your daily operation, but into managing, food waste, and also bring that into how to use machine learning to better engage the end user, the customers. So we do see that if you talk about facility management, it is getting more and more complex because nowadays facility managements have to deal with more and more complex systems with more and more regulations. And later I will also touch on what are some of the industry trends that we see, such as the sustainability green wave that might impact the facility management. So we do see that facility management are getting more and more complex, and precisely that is one of the key reasons we see that there is a growing demand for wanting to use machine learning and AI to help simplify a lot of these activities. So this is a very general applications that people ask us when it comes to applying machine learning and AI into building management or facility management. The common four questions that we always being asked to help implement is, the first one is something we call the anomaly detections. This is where, you know, you have all these data coming in from all these different sensors or subsystems, but it's still very labor intensive for humans to be monitoring all these data all the time. And you can imagine that a lot of these sensors are pretty much collecting data even down to a few seconds interval. So we definitely don't have enough manpower to be watching hundreds of sensors or even thousands of sensors from a building's 24/7. And this is exactly where machine learnings and AI can be used to simplify this. And I'll also talk about how the current existing traditional system in the market doesn't quite have the capability of anomaly detection, and where machine learnings can complement into that. The second part is a lot of the places that we have been working with, especially in Singapore, they already have quite a sophisticated building management system in place. And a lot of the organizations, they're also managing multiple facilities in a cloud. And one of the problems that we were asked was that there's a lot of false alarm coming from these systems. And after a while, the operators just tend to mute the alarm, right? So can we apply machine learnings and AI to detect these false alarm and to prioritize it so the operation teams can have an easier job to quickly scan through and resolve all these issues across either one properties or multiple properties, right? Again, this is something that human can definitely do, but it's too tedious for humans to be 24/7 checking all these alarms. And then a lot of the time, to verify the alarms, you need to get the raw data out, do manual computations, double check, cross check. So these are the things, again, machine learning can be coming to the rescue. The interesting point that Hansen was mentioning is really about the failure predictions and also the machine life cycle condition management, right? These are the two areas which the facility managements are trying to be one step ahead. Instead of the preventive maintenance people are doing, which is usually schedule based, we're now trying to, using the real-time data coming in from all these sensors and systems, we're trying to be one step ahead. So if we can predict accurately where these equipments will fail, what this will result into is that we don't need to have a manpower running around all the time on the monthly or even weekly basis to do these preventive maintenance. So again, the bottom line that we see, which is the driving force for all these technology adoption, is to really reduce the human effort for these kind of very labor intensive work. And also for a lot of the places, sometimes the facility management have to be taking care of the inventory as well, because when something breaks down, they need to have enough inventory to quickly resolve the issues. Again, with predicting maintenance using all these real-time data, it can also help companies to better manage the inventory, not have to overstock and etc. And avoid the issue of some key components break down and you don't have the stock, therefore operation will be impacted for a while. So these are all the areas, these are the common key areas that we see people are coming to us and asking us to see how we can apply machine learnings and AI into the traditional facility management. And a lot of people are always asking, you know, what is the differences between machine learnings and so-called advanced analytics and so on. So this is a simple slide that we're trying to use this to explain that, for example, you see the top hand side. This is traditionally how a decision is being made. You have data coming from all these equipment or sensors. Traditionally speaking, even for a lot of the building management systems or facility management systems, it's mostly thresholds based, which means you set a certain level parameters. If the data is above that parameter or below that parameters, it will trigger alert. And then based on the alert, the domain expert or the operators will look at these alert and decide what is the issue. So when you have a more complicated site, multiple alerts can be triggered, but then it still depends on the individuals to really analyze these issues and figure out exactly what happened. So in a way, the knowledge actually resides with the individuals. and then it becomes very tedious, you know, for these individuals to manage multiple sites and so on, because yes, there are system alerting them, but again, to figure out what happened, all these still takes time. And whereas for machine learnings, what it's trying to do is it's not going to replace the existing system, but more like an add-on lightweight parallel system that can help enhance the current operation. So instead of looking at threshold and setting, you know, different tens or hundreds of different thresholds across different data to keep track of what's going on, machine learning actually learns the patterns, automatically learns these patterns and store it into the database. And all the operator needs to do is review these patterns over time, can be daily, can be weekly, can be monthly. And once they review these patterns and they say that, okay, this is a pattern, verify patterns that always leads to a certain failures or certain equipment failures or certain components failure. Once that has been labeled, next time when very similar patterns comes up, the machines will right away identify. And you can imagine this learning process is not just between one machines and one domain expert. It's constantly happening across hundreds or thousands of sites and across tens or hundreds of these domain experts. So it really helps simplify the operator. So instead of always looking at the different threshold value, the operator just have to review these patterns from time to time. And when something happened, the machine will right away tell the operator, this is the condition, this has happened, mostly like this fault. So the whole verification becomes simpler, right? So this is really what the difference is between the traditional analysis versus the machine learning or AI approach. And this is just a side-by-side comparison, for example. I think on the left-hand side, many people are familiar with your typical PLC, BMS systems. You can see, again, a lot of these things are based on, you know, color-coded red or green. If there's alert, it will say alert on and off and etc. So when something happens, you see something flashing, the domain experts still have to go in to figure out why it's flashing, at which period does it happen, and do the troubleshooting. Whereas if you see on the right-hand side, this is something that we are implementing for chambers as well, is that when there's abnormal patterns happening, can be a short patterns or can be a long patterns, machine learnings will automatically identify these patterns and then record it as a timestamp. So the user just have to go to this interface through the internet or through the web browser, log in. They can click through these abnormalities, and then the machines will right away show them where is it happening, and then with the different labels, why is it happening, right? So as the people review these patterns from time to time, the machines will continue to learn from the site, continue to fine tune, and over the end goal really is that it can predict the fault much accurate. And even if it cannot predict, when the fault happens, it can quickly identify what has happened and what is the action needs to be taken care of, so that the engineers or the operator don't have to do all these troubleshooting from scratch or do all these validation from scratch, right? So this is really the comparison between what we call the usual approach versus the machine learnings and AI approach. This is getting a bit technical, so I'm just going to quickly scan through. But behind the machine learnings, usually these are the mathematical algorithms that these systems are comprised of. So you have something called unsupervised clustering, which are being used to identify the different clustering method. But you also have, you know, the algorithms, what people call the RSTM or the RN, where again, it's really just a mathematical equations to help identify from a pattern perspective how this can be automatically detected and also labeled, right? So it's not based on a simple threshold above this value and below this value and do what. So these pattern recognition algorithms can really help build up in terms of the complexities of a lot of these issues. So again, you have also algorithm like feature extraction and classification. Again, these kind of algorithm is really there just to help better classify or extract the key patterns so that it becomes easier for the operators or the engineers to review the issues. Because you can see visually, we can easily identify the abnormal differences, but when it comes to, unfortunately, machines, they need these kind of equations and algorithms to be able to automatically detect this and only tell user that this is the place you need to zoom in. You don't need to look over, the horizon of days and months of data to identify these peak, then analyze why these peak happen. The machines will identify that for you, so you can just zoom into the problems and label them as it is. Again, this is another method to do classification. Again, this is just to illustrate that these are the real mathematical approach behind what people call machine learning and AI. So it's not really a black magic or black box. It's really just these kind of algorithms that are functioning, can be multiple of these algorithms functioning behind a theme so that we can rely more on them and then don't have to do all these labor intensive identification work. Yeah. So again, back to the problem, why do people ask for machine learnings and AI? The fundamental approach is really to reduce the challenges in manpower. It doesn't matter if it's a developing country, very developed countries like Singapore, or emerging countries like some of our countries in our neighbors. At the end of the day, a qualified expert is really not abundance. It's really in the shortages across the world, I would argue. Because if you look at Singapore, a very developed countries, based on the BCA or NEA records, we have about 22 certified energy service company in the country, where in terms of I combine the industrial and commercial building together, we have about 28,000 of these buildings, right? So it's already a lot to deal with, especially now with government pushing on more sustainability mandate, which means there's more requirements for these people to take a look at these buildings. And when you go to a neighboring countries, the situation is really a lot worse. For Thailand, you have government recognized expert in managing facility. These companies, we have about 100. But if you look at the number of buildings, we're talking about millions. So we really don't have enough time to train these experts. And unfortunately, the youth these days, less and less youth wanted to enter into these segment as well. This is one of the challenges when I'm working with EMA. They also mentioned that, qualified energy engineering, this is something that we continuously see. There's a decline in the new blood coming into the industry. And there's a study that has been done by National Research Foundation a few years ago. You can see across different systems, and these are the systems that you usually encounter in facility management. On average, just based on the existing technology, which means we're not even talking about cutting edge technology. If people know how to better optimize these existing systems, know how to configure them, on average, you have about still 13% improvement opportunities, right? And the reason these kind of opportunity exists is really because we don't have enough manpower to go around and to make sure every system is optimized all the time. Especially now with COVID also, it further makes this situation a lot worse. So this is why we see an increasing demand in the needs of machine learning and AI, especially in the recent years. And this is what you see when it comes to the complexity of facility management. I would argue that facility management year on year is getting more and more and more complex. You can see there's a system level that a lot of these facility manager now needs to deal with. It's no longer just cooling, heating, and your basic fire alarms. A lot of the times they have to start to deal with a lot of the renewable related power systems, and when it comes to solar, and there's also new cutting carbon capture technology and etc. So more and more technology are being introduced at the building level to reduce the carbon emissions, which now becomes part of the responsibility for the facility manager, right? So in the system level, it's getting a lot more complex. At the hardware level, you have more and more sensors coming into these systems. Even when we talk about what Hansen was mentioning about digital twins, camera now also becoming a very valuable data sources coming in for analysis, right? Traditionally, people literally just use the camera to manually see if there's any activity, but nowadays a lot of these cameras are being fed into AIs or machine learnings to do more detection as well. So more and more hardwares are being deployed because hardwares are getting cheaper, and more complex of the software are becoming as well. And then you have different integrations between the cloud system, between the on-premise system, between the traditional BMS systems, and vice versa. So it's really getting a lot more complex. And this is where, a lot of the time, machine learnings can be used in these kind of complex situations to simplify things. And this is why we see, again, an increasing amount of people are asking us to use machine learning to detect fault detections. Because when there's so many systems interact with each other, when a fault occurs, it's very tedious for the engineers to troubleshoot to see where is the origin of the fault. This applies to commercial buildings. This also applies to very complicated industrial manufacturing buildings, operations. So to simplify that, just to give you some example, I go from the most simplest use case, and we can slowly build up the complexity so people can better appreciate where machine learning can be used. You have sensors on site, and instead of showing on your terminals in your computers when there's an alert coming in, nowadays, a lot of these alerts can directly being pushed through a chatbot, as Hansen showed similar examples earlier. But these chatbot can be telling you directly to your WhatsApp, to your Slack, to your Telegram, to your Line group, and etc. And we see, especially during COVID, a lot of the engineers rather to be all in one WhatsApp chat group, for example, with the digital assistant chatbot inside, so they can ask the chatbot, how is the equipment like in this? What is the temperature setting currently at this? And the chatbot, just like your e-commerce chatbot, they can answer all these questions, pulling all these real-time data from the different sites. And then the engineers and the chief manager can looking through all these conversations and keep track of what's going on here, right? So they don't need to be physically inside a so-called command center. It's now more and more we see moving towards this virtual command center. Either way, a lot of the operators are already operating using their WhatsApp group. We always discuss issues in WhatsApp group. We're now just bring the chatbot into the WhatsApp group so that it can pull real-time data for us based on our queries. So we see there's a lot of these kind of things happening in facility management already. And also the most important part that we see that people wants to reduce and remove is really the manual record reporting aspect. The problem with paper recording is, number one, it's you have stacks of them in your office. Then a lot of the time, these historic data is valuable, but because it's in paper format, the organization couldn't really take advantage to build up models, right? And also a lot of the time, if you're talking about human going to collect all these data, you can only collect once every few days or once every few hours, which the data frequency or intervals are not high enough to really for you to predict stuff. And that's why we see more and more people are asking us to digitize a lot of these reporting. So number one, you don't need people to go around to do these manual recording work. But two, all these data coming in the digital format can now contribute towards predicting maintenance, can now contributing towards to your automated reporting and so on. And then now a lot of the facility manager also needs to report to NEA on their water quality for their cooling tower, for example, right? Instead of having a vendor to always go up to your cooling tower areas and manually putting sensor, manually record them, we also start to see a lot of the shopping malls asking us to automate this whole process. So when for compliance reasons, they can generate the water quality report anytime during any intervals and without having manpowers to run around to do so. So again, this is really what we see also for the applications of machine learning and AI coming to the play once you have all these data available in your systems. This is where we start to introduce machine learning. So humans, we can see different trend chart, as you can see, but what happened is with machine learnings, when you have these kind of abnormal patterns happening, the machine learnings will automatically identify the time step. So as an engineer, I can literally just review through the different abnormalities in the weekly or monthly basis. Then I can focus on labeling and troubleshooting this instead of looking at the raw data all the time, trying to figure out what happened, because we simply just don't have time to do these kind of work. And once you label it once, as I mentioned, once the pattern has been labeled once, next time when similar things happen, the machines will right away tell you when it happens, what is the situations, what is the impact, and it can also quantify it for you. And then what's the recommendation you should do, right? And then for the engineers, they can either acknowledge or reject this. They can either directly go into the actions, or they can push these interface to the vendors to resolve these issues, right? So this also helps saves vendors time, because traditionally when there's an issue happen, the engineer or the operator might call the vendor have to send their team down, troubleshoot, figure out what happened, and then maybe arrange a second trip to fix the problem. But with this, everyone wins. You know, the operators, the engineers don't have to waste too much time troubleshooting. When an issue happens, when they can tell precisely what is the issue to the vendors or engineers, the engineers can go on site with everything prepared that needs to be used to address the issue. So it really reduces the needs to multiple trips down to a particular site and so on. So this is where we see there's a dramatic improvement when it comes to manpower optimization using machine learning. Again, machine learning cannot replace humans, cannot replace vendor, but it can use to be a good force to assist these kind of labor-intensive work. So it simplifies works for everyone else. And this is one of the applications that we have been asked to implement. There's a lot of more complicated system. A lot of the facility manager are now managing multiple sites with very complicated BMS systems or even digital twins, right? So when you have all these data come in, how many of these alarms are real alarms? How many alarms are false alarms? That is very troublesome for the operators to manage, right? So again, we are leveraging our machine learnings because these machines, they can have the ability to analyze all these data from a physics, thermodynamics perspective. So when some data come in and the whole physics logic defies the fundamental physics principle, you can pretty much assume that this is a false alarm. So there are many methods like this that the machine learning can implement and quickly check against all these alarms. How many are true and how many are false? And when they prioritize these for the facility operators, they can focus on the true alarm first. After the true alarm has been resolved, then they slowly go back to resolve these false alarms with the more pinpointed approach, right? So this is exactly another example where machine learning can help improve these situations. And finally, when it comes to sustainability compliance, you know, exactly using these real-time data to predict your equipment health, so you can move from preventive to predicted, but also to help keep track of your energy savings and your potential opportunities for energy saving. Traditionally speaking, you need to have consultants to come on site and help you do a lot of these verifications and double check and stuff. Now with the data, the system can give you a high level ideas of where's the energy going to. And again, these data can be easily shared to your vendors and your partners, and they can come in and do the work much easier and reducing all these manual work. So this is really something that we see the machine learning can help improve the situations. And traditionally speaking, you know, if you look at the business model also, we now see a shift. Traditionally, people are talking about buying BMS systems, hiring consultants or experts and third parties to do all these things. But with machine learning come about, we learn from the software industry now, these are things that we call as software as a service, right? So instead of paying an upfront system cost for many of these things, we now see more and more companies are offering these kind of subscription costs, which is much more affordable also to a lot of these smaller sites. So we do see that not just the technological advancement in machine learning, business model wise, we also see innovation in the market that has been helping the facility management. So I'd like to wrap up my presentation with a video that was made by the Singapore Tourism Board with one of our innovation challenges, which was started in 2017. So this is where we were exploring how to use machine learning for the first time into a hotel operation. And really the objective is to help them reduce their manpower. And also this is supported by the Singapore Tourism Board with the Pan Pacific Hotel Chain. So I'll play the video so you can see all these components are working in one holistic manner. And I'll wrap up my presentation with this video.
In line with Singapore's Smart Nation vision, one of Pan Pacific Hotels Group's operation goals is to achieve higher productivity through technology. In 2017, we partnered local startup Evercomm Singapore to pilot a centralized predictive maintenance solution at Park Royal on Beach Road.
We found that our staff were spending a lot of time collecting, processing, and reporting data for our chiller plant operations. They are usually fully deployed on scheduled tasks, including routine on-site inspections when we receive ad hoc emergency requests. Our maintenance planner has to manually send a work order to the supervisor, who could then assign the job. Upon fixing the equipment defects, a manual report needs to be filed before they can report to the management. The Innovation Challenge 2017 by the Singapore Tourism Board was timely, as we had planned to upgrade our aging system to an automated one. Using the digitized chiller operations management system, we were able to improve our workflow, efficiency, and productivity, as our associates can now access chiller plant data on a real-time basis. Upon implementation, we're able to achieve a 50% reduction in human effort savings, or 0.4 FTE savings.
We can now remotely monitor performance of SVSE systems, specifically chillers, heat pumps, and air handlers across multiple property via our dashboard on web and mobile. The data enable us to develop a system that is able to predict maintenance work and manage the SVSE system centrally. The AI assistant can predict breakdowns of the chillers and send alerts to us via the AI chatbot or web app. This reduces the need for us to conduct on-site inspections or troubleshooting, thus improving our productivity.
The system is supported by its own wireless sensor network and protocol in order to avoid potentially interfering with the hotel existing Wi-Fi network. This IoT infrastructure framework is also supported by an open source networking technology, which allows us to use low-cost hardware and embedded systems, instead of relying on the costly proprietary hardware controllers. We follow the design thinking methodology in order to overcome the challenge of designing the centralized system. A cross-functional team was formed, including facility experts, data scientists, in-house engineers, technicians, as well as our third-party domain partners, in order to brainstorm the existing operational problems, generate design options together, and finally define the right design criteria for the centralized system.
Good change management played an important role in managing the operation associates' concerns. We conducted classroom training to share the benefits and importance of a centralized system. The new system was installed in parallel to the existing system, so that operations associates can try out the new system without operational risk.
We are implementing the solution in other Pan Pacific and Park Royal properties in Singapore. We are also exploring the possibility of adopting further enhancements, such as building digital equipments and energy profiles across different types and models of equipment. Pan Pacific Hotels Group is open to exploring new solutions. We look forward to supporting Singapore's startups and contributing to the development of the hospitality industry, as we strive to maintain our position as a leader in sustainable hospitality.
Yep. So that was it from my side. Yep.
Okay, thank you, Hansen, and thank you, Ted. So in the interest of time, we will probably just take one question. So with reference to the machine learning models developed for predictive maintenance, would model generalizability be an issue? i.e., considering the uniqueness of buildings, models developed using specific building data would not necessarily be applicable for other buildings?
Yeah, the answer to that is both yes and no. So for example, traditionally, when you talk about machine learnings, a lot of if the machine learnings are pre-trained by the companies, and then there's no ways for the operators to feed back into this system, then that question will be valid, because each site, one site's data or the one site's learnings cannot be replicated to the other side. But what we mentioned earlier as part of the innovation challenge we have done, the whole idea is that we bring in the operators and the engineer in the loop from day one. So that's why I say we cannot replace domain expert, we cannot replace the engineers. They still need to be in the loop to review a lot of these activities. So as they review the results from these machine learnings and correct it accordingly, we can now do mass customizations across different properties. Therefore, it's not just one algorithms and one results for all the properties. Every property through the input from their operators, it will fine tune for that particular property's results.